statistics come with a lot of data. What do we do with those data? How do we present those data to answer our question? So in a way, a lot of time we use those data in graph. It's the easiest way to show that to everyone. Hey, look, this is the visual representation of the set of the data that we receive. And from there, we can answer many questions that we come up with originally. Now let's talk about the stem graph, stem and leaf graph, line graph, and bar graph. First, stem and leaf. The stem and leaf plot, also known as the stem and leaf diagram, is a method of representing a set of numerical data. It is visually display the distribution of a data set by organizing the value into stem and leaf. So here's how you can create a stem and leaf plot. First, you sort the data, arrange your data in ascending order, determine the stem and leaf. The stem is the leftmost digit of each data point. The leaf is the rightmost digit of each data point. Then we construct the plot. Write the stem in the vertical column with the smallest stem at the top. Write the leaves next to their respective stem. Okay, so here we have a set of data and it already pre-sorted for you. So let's say this left column is the stem and the left is leaf, the right is leaf. The stem is the leftmost digit of each data point. So 3, 4, 5, 6, 7, 8, and 9. So I write that in 3, 4, 5, 6, 7, 8, and 9. So in stem, I have 33, so the leaf is 3. In the 40, so 42, 49, so the leaf is 2, 9, and 9. 40, in the 50, we have 53, 55, 55. In the 60, we have 61, 63, 67, 68, 68, 69, 69. In the 70, we have 72, 73, 74, 78. In the 80, we have 80, 83, 88, 88, and 88. In the 90, you have 90, 92, 94, 94, 94, 96, and we have 100. So here's 1, 0, 0. Okay, so that 100. By looking at this, we can see that here we have the set of data of the pre-calculus class score for the first exam. So note that. So it seems like we have most people is score in the 60 to the 80. Right? The stem plot is a quick way to graph the data and give an exact picture of the data. You want to look for an overall pattern and outlier. The outlier is an observation data that does not fit the rest of the data. It's sometimes called the extreme value. When you graph an outlier, it will appear that it will not fit the pattern of the graph. Some outliers are due to mistake, for example, writing down 50 instead of 500. While others may indicate that something unusual happening, it takes some background information to explain outlier, so we will cover them in detail later. Take a look at our next example. The data represent the distance in kilometers from a home to the local supermarket. Create a stem plot using the data. So here, I will have the digit number as the stem. And the decimal as the leaves. So we start with 1. Stem 1, leaf we have 1.1, 1.5. Stem 2, leaf we have 2.3, 2.5, 2.7. Stem 3, we have 3.2, 3.3, 3.3, 3.5, 3.8. Stem 4, we have leaf 0, 2, 5, 5, 7, 8. Leaf 5, we have 5. No, stem 5, we have leaf 5, 6. Stem 6, we have leaf 5, 7. And then we have stem 12, leaf 3. So note that this number here, 12.3, it is a lot bigger than the all other number, right? So this means 12.3 could be an outlier. 12.3 is an outlier. We don't know whether that is the actual distance from the home to a local supermarket. It could be the other supermarket on the other side of town, or it could be there's a mistake in writing down the distance. It could be, say, 1.23, but the observer write down 12.3 on accident. Now, we also have a side-by-side stem and leaf plot. It is a way to compare two sets of data by displaying their stem and plot next to each other. It allows for visual comparison of the distribution of the two data sets. Let's consider the two data sets and actually write it down twice. We cross out the A and the actor set B. When we compare the two data sets, we will have the stem as the column in the middle, and the leaf is of two sides. So on the left side, we have the data A, and this is data B. So the stem of both is 1, 2, 3, 4, 5. Okay. So in data A, we have 15. We start with the data set A, 22, 25, 33, 34, 36, 4. You have 41, 42, 44. We don't have anything on 5. In stem B, we don't have anything on 1, but we have 8 on 28, 32, 35, 37, 41, 45, 47, 51, 53. So you can see what are the distribution on each of those data sets. Line graph. So you done this in algebra. Line graph have the x-axis and the y-axis. Okay. So the line graph is the type of chart that displays the data point over continuous interval of time or span and connect them with a straight line segment. This is commonly used in visualized trend and change in data over time. Here's a step to create a line graph. You collect data. Gather the data point that represent the value you want to plot. The data should have two variables, one for x and one for y. Choose the x-axis. Decide which variable will go on the x-axis and which one go on the y-axis. The independent variable, usually time or another continuous variable, typically go onto the x-axis, while the dependent variable go on the y-axis. You then will scale the axis. You plot the point, you connect the point, then you add label and title to your graph. So here we have a graph represent the temperature. So the x-axis is the month. The y-axis represent the temperature. So note that the temperature here, the highest temperature is like 28. So I will divide my scale in terms of 5, 10, 15, 20, 25, 30. And the bottom we have months, so 12 months. So January, February, March, April, May, June, July, August, September, October, November, December. Okay. So in January, the temperature is 10 degrees. So 1 corresponds to 10. February 12, so it's a little up. March is 15. April is 18. May is 22. June is 25. July 28. August is 26, so the temperature going down. September 23. October 20. November 15. And December is 12. So we can see this is the line graph that we come up with. Okay. So what is the name of this chart? This chart is the temperature in 12 months. Let's talk about bar graph. Bar graph consists of bars that separate from each other. The bar can be rectangle or they can be rectangular box used in three-dimensional plot, and they can be vertical or horizontal. So for example, by the end of 2011, the Facebook have over 146 million users in the United States. The table below shows 3 age groups, the number of users in each age group and the proportion of users in each age group. Construct a bar graph using this data. So I will go ahead and construct this bar graph using the proportional using the age group and the proportional of the Facebook user. Okay, because it's easier than to try to make a scale with large number. On the x-axis, I will have age group. On the y-axis, I will have the proportional. So to here is 100%, 50, 25, 75. In the first age group, it is 13 to 25, and that is 45%. So 45%, I draw in a bar, and I write this on top, 45%. In 26 to 24, so again, here's another bar, 26 to 44, 36%. So it's approximate this much. And the next one is 45 to 64. It is 19%. Note that the A group here, the width of this A group, they are not the same. Okay, the width of this A group is 12. This A group here is what is 44 minus 26? 18. 64 minus 45, this is 19. However, when I draw this bar, in this bar graph, we're just talking about the A group, certain A group. So this bar does not have to be the same size, the same width. The bar does not have to be at the same width. However, the vertical have to represent the proportion. So the Y value is what really showing the difference here. So note that here the number of the people who use Facebook are 45% in the age of 13 to 25 years old.